We are talking here about integrating IoT and AI for achieving net zero water in agriculture. So we all know that we are using a very large amount of the water, which is a scarce resource in the economy, in the sector, agricultural sector, because we are using almost like 80% of the water. And we all know that we need to harness some amount of technology to transform that how we are managing our water in the spaces where we are living, where we are working, and we are connecting, not just in agricultural sector, but also in the entire horizon wherever we are living, working, and connecting. So, first we'll talk about a little bit of the global rise of AI in agriculture. So, we know that AI market in agriculture has projected to reach around 4.7 USD billion by 2028. That is a CAGR of 23% almost. And AI adoption is accelerating in precision farming, as Dr. Koti Reddy highlighted, and also crop monitoring, irrigation management, and supply chain optimization. When we talk about agriculture, we just not talk about the farming, but also we talk about the entire farm produce that is being to the households or industries in terms of supply chain optimization. Another point that has been highlighted is AI powered weather forecasting that helps farmers planning irrigation and reducing the yield losses. There is also the satellite and the drone based AI imaging, which enables early detection of the crop stress and pest problems and nutrient deficiencies. So, in this way, what we do is we try to optimize the water savings and water use, and also we try to achieve 34% savings in the water consumption. Now, machine learning as of these days, it's very prevalent. AI, ML, that is artificial intelligence and machine learning models are predicting the yields, software moisture, soil moisture, the disease outbreaks with the big data and the IoT sensor inputs. So, autonomous tractors, AI enabled drones, all these are transforming the farm operations and labor efficiency. And AI in the livestock management also is improving the feed efficiency, animal health, disease detection, etc. Because when we talk about agriculture, we also talk about the allied activities, that is the livestock management. Now, in countries like US, Israel, Netherlands, India, and China, these are all leading global innovation in the AI-based farming. And agricultural economists do take a lot of examples from micro irrigation in Israel, because this most of its water in the irrigation as recycled water. That means they do not use fresh water in the agriculture. Now, integration of the AI, IoT, GIS, blockchain, creating very smart and traceable and climate resilient agricultural systems. And we also have heard about global initiatives like FAO and digital agricultural framework and World Bank's agri-tech programs. All these are promoting AI in sustainable agriculture. Now, all these contributes to a very resource efficient and low carbon data driven farming, which support the sustainable development goals 2, 6, 12, and 13. So this is giving you a cover story of the global rise of AI in agriculture, basically getting you the facts and figures. Now, we know that India is a global south leader in mainstreaming AI in agriculture. We have just started it. Now, India AI Mission 2024 was launched with an outlay 10,300 crores, which was almost equal to $1.25 billion to build a national AI ecosystem. So, see, in my previous workspace, I was working with the government of India, Niti Aayog, where we have learned a lot about Niti Aayog's national strategy for artificial intelligence. So there was a core priority sector which was continuously believing in AI mission. And we not only create AI for agriculture or a specific any other sector, but we promote an AI ecosystem. That is a better word to describe. Then AI powered mobile apps these days. Most of us are using mobile applications, and the farmers are also using to diagnose the crop disease and get real time advisory on the yield and soil health. Then digital agricultural mission also allocated to almost $321 million for a digital first and data driven farm ecosystem. So you see, all this money that has been allocated into different policies of the Indian government was mostly to build up agricultural startups, to start a dashboard with AI and IoT, so that that vast stretches of the agricultural land that we have, we do not have to manually go and check that which crop has pest infected or which of the soil has been affected by any kind of germs, etc. That's beyond impossible. So what we are doing is we are trying to be more and more scientific. We are trying to be more farmer centric AI and IoT solutions. Then top investors, we know this Omnivore, Bloom Ventures, Birak, all these are supporting the AI driven agricultural innovation. So combinedly we are having a public private effort to build a smart, inclusive and climate resilient agricultural sector. Now, first in my introduction, I think I talked about a word that is a need for net zero in agriculture. So throwing some light on that what do we mean by net zero? Agriculture, we all know that consumes almost like 80% of India's fresh water resources. And here we need to very much focus on the word fresh water, because we are not using still recycled water in agriculture. We are using fresh water, which is not easily available in our country. Now the water stress is growing. There is erratic rainfall. Some major amount of the rainfall happens in South India and the north gets none. The depleting the groundwater demands smarter use. So net zero water is basically balancing the total water withdrawal with the total water return or reused. What am I doing? As an economist, as an environmental ecologist, or whoever, as a person that I know that I need to balance the water, the amount of the water that I am taking out from the ground, I need to replenish it with the equal amount of the water or maybe more than that. So in that way, how we will do? We will balance the total amount of the withdrawal that I have taken out. So that is called net zero water. You students must have heard that when municipal corporations these days come with their bore diggers and they come and dig into the roads to find the groundwater level. So initially when they used to go 20, 30 meters deep, they used to find it. But now finding an aquifer has been very difficult because the deeper they dig in, they find that groundwater level has depleted horribly. Now, through IoT and AI offer tool precision and prediction and optimization across the water cycle, we learn that if we are using more than 100 KLD of water, that means groundwater, and we need to replenish or aquifer management by the treated wastewater to balance the nature. So that is nothing but which is called we are maintaining net zero water. Coming to the concept of net zero in agriculture, that is achieved when water use is equals to water replenished or reused within the farm system, involves water use efficiency, reuse, rainwater harvesting, groundwater recharge, etc. It emphasizes a circular water economy, that is every drop counts and is reused. And it is also supporting the SDG 6, which is clean water, and SDG 13, which is a climate action. That means however much water we are using, let us replenish back into the nature by aquifer management or groundwater recharge, etc. Now, role of IoT in achieving the net zero water. Now, IoT is real-time monitoring of the soil moisture, humidity, rainfall, evaporation and evapotranspiration, then IoT sensors for precision irrigation scheduling, reducing over irrigation and losses. Now, in Indian agriculture, the biggest problem is many a times what used to happen is we water more than required. So, what we are doing is we are decreasing the water use efficiency. However much water is required for the soil moisture, we need to put that much of the water, and the rest is getting drained and wasted into the seas and the oceans. So we need to stop that by use of IoT, an automated irrigation system controlled via mobile or cloud-based apps. Now, smart meters and flow sensors to track the water input output balance, and also a drone based surveillance for field water mapping and vegetation index. Now, one thing we see here is key statistics shaping Indian agricultural AI. More than 265 million people work in agriculture in India, making widespread AI adoption essential for the nation's food security. The agricultural sector contributes nearly 20% of the India's GDP, amplifying the economic impact of AI-driven solutions. And forecasters showing that Indian agricultural AI market could see CAGR growth above 25%, which is quite a dominant percentage through 2025. So we can say that over 70% of the Indian farmers may access precision farming technologies powered by AI by 2025, revolutionizing traditional practices. Integrating IoT and AI, which is a smart water cycle in agriculture. Now, till now, we have learned a lot about how we use IoT, how we are using so much of AI. We are trying to make smart water cycling a circular economy in the agriculture. So, what do these IoT sensors actually do? IoT sensors actually collect very high frequency field data, moisture, rainfall, the acidity, that is a pH level, salinity, and all this data is transmitted to the AI platform, analyzed for the trends and predictions. The system sends automated commands to irrigation units or alerts to the farmers, and then it enables a closed loop self optimizing water management system. This in turn promotes net zero water farms through continuous reuse, recharge, and reduction. So I have just told you that how a complete process works. You bring a IoT resource center and that data is transmitted to the AI platform. Then automated commands to the irrigation units are sent. That enables an optimizing water management system, which in turn is bringing net zero. So this process seems to be very smooth, which is drawn by a very, a quantitative structure. It's a data analytical structure which is helping me in precision agriculture and smart water cycle in agriculture. Now, the digital tools and technologies which are used in IoT networks are like IoT satellite telemetry, GIS remote sensing, which is mapping water and footprints, recharge zones, then AI platforms, which is TensorFlow based predictive models for the irrigation, drones help us in crop water stress detection via NDVI imagery. It clicks very close precision pictures of these plants if any kind of water issues are there, water stress is there, or any kind of pest infestation is there. And ultimately, we lead to the blockchain for transparent water credit trading and traceability. Now, looking at this map of the world, we see that water stress, how it is, and a country-wise water stress map is here for your highlights in 2040, that we see the extreme is higher than 80%. We come, the Asia, Australia, all these parts of most parts of our country is covered in red, which is showing that it's extremely high, that is higher than 80% of the water stress happening in the entire world. Now, talking about a comparative index of India and rest of the world is the world population, renewable water resources and land area, where we see that India is having 16% of the world population, 4% of the renewable water resources, which is extremely sad, and 2% of the land area. So from this picture, we understand that how much vital it is important to recycle the water, to reuse the water, and also to understand how to replenish the water. Himalayan glaciers and annual monsoon sources of water are there, but as many of the economists, and definitely these days we can see ourselves with our own eyes, that how climate change is highly impacting the erratic rainfall condition in our country itself. Then we come to India's water scenario, where we talk about the total rainfall is around 4,000 BCM. Available amount of the water, per capita water, and utilizable water are very much different from each other. So surface water is around 690 BCM and groundwater is around 450 BCM. And so we understand from here that its contribution of the groundwater is nearly 62% in irrigation and 85% in the rural water supply and 50% in the urban water supply. Agriculture consumes around 73% of the total water resources. Our international trade is contributing to large quantities of virtual water loss through the export of the water intensive crops. And only 304 BCM out of the 690 BCM is stored. That means only 44% of the water is stored. So from here we learn a very important concept, which most of you must have heard about, is the water use efficiency in agriculture, which is around 38%. Domestic water losses are 35 to 45%. Industries are consuming 200 to 300% more water in per unit production. So from here we get to know, and India's water scenario is quite in a deplorable condition, where we need to work towards the increase in the amount of the use of water use efficiency and reducing our water footprint. Now, a comparative diagram is given with Brazil, China, and Israel. So Israel is doing very well in terms of micro irrigation. We know that it's around 51.6% of the water is used in irrigation, and India is using 91%. But definitely, you may say that yes, Israel in comparison to India is a very small country. But you know, AI and IoT based technologies, that is very much faster in countries like Brazil, China, and Israel. So we definitely need to learn a lot from them so that we can use our precision agriculture and increase our water use efficiency. Now, smart water systems, as I told you already, that these IoT sensors, how do these actually work? They work like they continuously track the flow rate. Suppose from a pipe, continuously water is flowing. So they track what is the speed of the water, what is the pressure level, water quality parameters, instantly detecting the anomalies through the building infrastructure. So if there is a building of 5 floors or more than 5 floors, maybe 15 floors, it will check at each and every floor what is the water pressure, what is the flow rate, and different other water quality parameters, as I told you, salinity, pH, etc. So these sophisticated algorithms predict the demand pattern, automate the intelligent responses, and deliver actionable insights to facilitate managers in real time. And unified platforms enable seamless monitoring, control, and optimization of the water systems through entire building portfolio from a single interface. So IoT and AI analytics actually create an entire cloud of the data, where we get a comprehensive ecosystem that is transforming passive water infrastructure into a very intelligent, responsive system capable of unprecedented efficiency. Because see, when any natural calamity will come, obviously it won't inform us before coming, but these days we get news highlights like cyclone, so and so cyclone is coming at so and so speed, wind at the speed of so and so is traveling from here to here, so all the fishermen are told to be out of the very far from the seashores, etc. So these type of natural calamity managements we get to know, right? That is definitely to safeguard, and we are using what IoT sensors and AI analytics. Similarly, we need to use this cloud data, we need to use the sensor management in our Indian agriculture. Now, integrated IoT and AI framework is working like it is working through data collection, it is making a circular water flow, and it is also working in cloud analytics. So this entire integrated framework is creating a very self-learning. We all don't know what might be the result. The result might not be positive as well. But this is a learning by doing process, which our economics arrows theorem says that self-optimizing water management system that continuously improving efficiency. So predictive maintenance capabilities are reducing downtime and preventing the water loss before failures occur. So let's not sit like anytime failures can happen, but we are like always prepared for the worst, and we give us supporting circular economy principles. Now, precision detection, instant analysis, all these are system triggered automatic valve shutoffs to prevent costly water damage. What happens when immediately a valve might push out water, the speed of the water may be too much and the valve might just break. So, in order to avoid this type of costly water damage, wastage, and structural problems, what we do is we continuously monitor data. As I told you, we continuously monitor the water flow and the water pressure. And we know that Singapore's smart water grid has reduced the water losses significantly through AI powered leak detection, setting a global benchmark for the urban water management excellence. Now, enhancing the water quality and safety with AI monitoring, as I told you, that we are not only tracking the pH level, turbidity, chlorine concentration, microbial contaminations. 24/7, we are ensuring constant vigilance over water quality parameters. Next is some government initiatives related to the water management. We know Jal Jeevan Mission, Bureau of Water Use Efficiency, and Atal Bhujal Yojana. So all these yojanas or the policies which were launched in and around 2019 to 2024 have worked under the promotion, regulation, and control of the efficient use of the water in irrigation, industrial, and domestic sector. Now, one important point that I want to focus here is improvement of the management of the groundwater resources. It's including the rainwater harvesting in water stressed areas through community participations in different states where the water is stressed. So we focus on topics like rainwater harvesting. Then there is one more initiative like Bharat Tap, where Ministry of Housing and Urban Affairs has launched efficient plumbing fixtures called Bharat Tap. Then there was the Gazette of India here is showing liquid waste management. That means before treating any kind of the water or liquid waste, you cannot throw it or push it into the sea or the ocean to get the entire water resource get contaminated. And Amrut too, which was launched with mandate the cities to carry out reforms like water conservation and recycling and reusing of the water, rooftop rainwater harvesting, water efficient plumbing fixtures, energy efficiency, etc. Now, Niti Aayog had a very nice and very good guideline on the water neutrality. We talked about improving the water security, reducing the environmental impact of water scarcity and pollution, improving industry's reputation, builders' stakeholder trust, demonstrating commitments, etc. It's very much available in the internet. So if you want to go through water neutrality for Indian industries, you may. And different type of the policies and missions, if we can see the role of IoT, AI, digital tools have been very, very prevalent. Like policies like per more crop per drop. So this line itself means increasing water use efficiency, then automated water control, then rainwater harvesting, water budgeting, groundwater recharge, data transparency and community participation. So all this is actually fostering your circular water use, and it is driving the real-time irrigation optimization, laying the foundation for the net zero water farming systems. And comparative innovations with the impact table, if we talk about, is different type of innovations. If we see, I have just tabulated some different type of the innovations. Just focus on the estimated reduction, cost reduction is almost around 20 to 25% of the cost has been reduced, which is a very high sustainable impact. That means we are not only reducing the water usage, we are not only reducing the pesticides usage, but also we are doing a reduction in the entire cost of the product. Wider adoption of sustainable farming practices, less crop loss, and improved food quality and trust. Now, AI IoT success stories, some are there like Microsoft and ICRISAT had a very nice success story which happened in Andhra and Telangana. I won't get into the detail of the story, but I'll just tell you that what amount of the farm productivity it increased. It was like 10 to 15% and reduced cost inputs. Then there was a Fasal startup in Bengaluru which talked about farm sensors and AI analytics, which achieved around 50% in the water savings in horticulture crops like grapes and pomegranates, and so on and so forth in mostly in Bangalore and Andhra Telangana. And also one happened in Bihar and UP. What happened is IoT sensors for pond water quality monitoring. So what happened here? Impact was improved water quality and efficiency in aquaculture, meaning saving the fish, etc., and reduced manual testing over by 70%. There are definitely challenges with IoT. The challenges are initial hype. We are very new to this concept, and connectivity gaps are there in rural areas. It's difficult to find connectivities, limited farmer awareness because farmers are not very much aware of this type of it's too much IoT and sensor, etc. They do not have this digital literacy. So, a vision for the future would be move from water consuming to water positive agriculture, AI driven decision making for the water neutral farming, building integrated digital systems linking the farm water, weather data, empower the farmers, and also achieve the net zero agriculture through technology, policy, and participation. And so, all I can say as a water steward in economics is together, let's be the driving force behind our country's water secure future. Thank you so much.